Have you ever seen a rainbow across the sky? It is one of the most incredible sights in nature. So, what is a rainbow and how is it formed? The light from the sun appears white to our eyes. However, it consists of many different colors: red, orange, yellow, green, blue, indigo, and violet. The order of the colors contained in white light is called its spectrum. Each component color of white light travels at a different speed in a medium. Red light has the highest speed, while violet light has the lowest. Because of this, when white light goes from one medium into another with a different density, red light, which is the fastest, is refracted less, while violet light, which is the slowest, is refracted more. Since each of the component colors in white light is refracted at a different angle, the colors become separated from each other. This effect is called the dispersion of light. We can observe the effect of light dispersion with a glass prism. When white light enters the prism, the different colors start to spread apart due to dispersion. As the light rays come out of the prism, they are further separated from each other. The formation of a rainbow is also due to the dispersion of light. In this case, water droplets in the air act like prisms and cause sunlight to be dispersed into its component colors. A rainbow usually forms when the sun comes out after the rain has just stopped. To see the rainbow, we must face away from the sun and look at the sky. The sunlight that comes from behind becomes dispersed by the water droplets in the air. We see the red light from the water droplets that are higher up, and the other colors from the water droplets below. Together, the component colors of sunlight dispersed by the water droplets form the magnificent sight that the rainbow is.
Hi, my name is Niranjan and welcome to another episode of Champak's IQ, where we teach you simple science experiments that you can try at home. Now, depending on where you live, it's either raining or it's not. But irrespective of that, the best part about the rain is the rainbow. But because it's kind of rare, you're not going to be able to see much of it. But I'm going to teach you how to make it at home so you can see it whenever you want. So what are we going to need for this? Well, we're going to need some water, a bowl, a mirror and a phone. Well, really the tiny LED that's on the back of this phone. So let's get started. So we start off with a little bit of water in our bowl. Now the idea is to fill it up almost to the top, but leave just a little bit, and I'll explain why. Alright, so we have enough water. Now we take our mirror. Now because mine's an L-shaped mirror, I'm not going to bother taping it down, but I would recommend that you do if you don't have an L-shaped mirror. Place it at an angle in the water. Now half the mirror should be underwater, because this is where the magic happens. So now when I take my torch and shine it into the half of the mirror that's underwater, and on this card that I've placed here, you get the rainbow. How cool is that? Now if you can't see the rainbow really clear, you should try turning the lights down, or maybe make sure that no light falls on the card that you're capturing it on. Now let's move on to what's happening here. Now before we begin, let's establish that visible light, white light, is actually made up of 7 colors. So when we shine light on the part of the mirror that's underwater, the light bends as it moves from air to water. But because the components of white light travel at different wavelengths, they bend to different degrees. These colors are reflected by the mirror, which you catch on the piece of the card. Now light travels in waves. Now a wave is an oscillation or a disturbance that travels through space. This is why we can't see the other components that light is made up of. We can't see components like ultraviolet or infrared because their wavelengths are either too long or too short. Now a wave is made up of peaks and troughs, and the distance between the peaks or troughs is the wavelength. And it's not just light that travels in waves, sound travels in waves too. So do radio waves, microwaves, and a whole bunch of other things, including me. Because I am going to wave goodbye, and I'm going to ask you to try this at home and leave your thoughts in the comments below. My name is Niranjan. Thank you so much for watching this episode of Champak's IQ. Please subscribe. This was brought to you by Champak and One Network.